So I'm going to stop sharing there for a moment and then open these guys to share here. All right, and let me just rotate this. This is a student's work from a couple years ago. Rotate. Rotate. Oh, that it is. All right, so we're going to draw ours like this, which is basically going to show all the components of the instrument kind of in a line here so we can understand how they're all connected. But here's how another student in the past has drawn them. He said, I want to draw it exactly like I see it on the instrument. Kate's eyes just bugged out there. So, but this was how like his understanding was. And so this is what the instrument actually looks like. So let me zoom in on this picture here. So he wasn't far off in terms of what the instrument looks like. But what I'm going to do is I'm going to go through the scheme first, and then we'll kind of come back and we'll map it onto this picture that we have here so you can kind of see how that works. But so I'm going to share my screen again here so that we can draw through what this scheme looks like. Has anyone ever had to draw a scheme for another class? I know if you've taken like instrumental analysis, you have to draw a scheme for that. Has anyone done this in another class before, drawn a scheme? Okay, so essentially we're just drawing, imagining this as being a start to an end of our instrument. We're going to start, the starting point is really taking two buffers that we have here. So I'm going to have buffer A and buffer B. So every time I'm drawing a box here, this really just represents a component of the instrument. And anytime I'm connecting two boxes, that really represents tubing that's connecting these two parts of the instrument. So what I have here is I have a buffer that comes from one flask and a buffer that comes from another flask, and they're each going to lead into a mixer. So that's sort of our next component. And not surprisingly, what the mixer does is it's going to mix A and B together. Okay, so what we'll see with this schematic and how this instrument works is we're basically doing column chromatography. So hopefully all of you guys have done or remember column chromatography from organic chemistry. So a lot of the principles are going to apply here, but what we're doing is we're automating the process and almost having it like it's an assembly line. So a lot of it's going to be sort of done for us. And so we'll talk about how that happens. So we'll have the ability of having two different buffers that we can use. And in essence, any sort of concentration combination of them, because our instrument will be able to pull different ratios of them together. So we'll have anything from 100% A to 100% B to everything in between, depending on what our instrument tells it to do. So after we leave the mixer, then we're going to go to a pump. So this is a peristaltic pump. And if you know anything about peristalsis of your intestines, it's a rhythmic contraction that moves things forward. It's the same way that you can actually get toothpaste out of your, out of your toothpaste container, is you actually provide a pressure to it. So this pump is actually going to push things past it, which allows you to pull things toward it. So this is how we're going to keep our mobile phase moving through this system. So the purpose of this pump is to move the mobile phase. So remember, when we do chromatography, there's always two phases. There's the stationary phase, which stays still, and we haven't gotten to that yet in our kind of schematic here. And then there's the mobile phase, which moves through. So our mobile phase is really what we have here with our buffers A and B. And so the pump is going to be moving that mobile face through. Okay. The next part we get to is called the sample injector. And I'm going to leave this guy blank for a minute. We're going to come back to him because what I want to do is I want to show you sort of the main line of the instrument. And I'm going to use sort of a bus analogy here. And I'm going to say, imagine we're not stopping at the bus stop. We're just going from start to finish. We're not stopping anywhere. So I'm going to kind of show you the route through without any stopping. I'm just going to make this look a little bit bigger here. So this is my sample injector. Okay, so the next stop along this pathway is going to be our column. And this is our stationary phase. So this is where we're going to have a lot of options in terms of what we can use as our column material. Sometimes this is also called a resin or beads. This is whatever you're putting inside your column. So if you did a column in organic chemistry, it may have been a silica column or something like that. So it's whatever material you're putting inside of your column. The next stop along this pathway is a UV detector. This is a little spectrophotometer that measures two wavelengths. It measures 260 and 280. One of these measures protein and one of them measures nucleic acid concentration. Does anybody remember which one is which? Which one of these is protein?
Is proteins the first one?
Protein is 280. But thanks for guessing. You had a 50-50 shot, right? So protein is 280, DNA and RNA is going to be 260. So we've got this little spectrophotometer that we have here. The next stop along our pathway is going to what we call a conductivity meter. And this basically measures ion concentration. This tells us how salty our solution is. So there's lots of things that could be contributing to the saltiness of a solution. It actually might be salts themselves. We might have proteins that are charged. We might have nucleic acids that are charged. All kinds of things could contribute to the charge we might experience in our solution as it passes through this conductivity meter. The next stop that we're going to have here is called a diverter. Okay. Now, what a diverter does is it can divert between two different places. We can divert to waste if we're not interested in saving whatever's coming through, or we can go to our fraction collector. Now, when you guys did column chromatography in organic chemistry, you were probably the fraction collector. You sat there with a test tube underneath as stuff dripped out of your column, and then you had to change to another test tube, okay? This instrument actually has a little robotic fraction collector so that it will know when to change to the next fraction. What's really neat is this can communicate with the UV detector and the conductivity meter. So you can use information about what's coming through the pipeline to say, you know what? If the UV detector isn't registering anything, meaning that there's no proteins, go ahead and divert to waste. I don't need to have anything. Or, hey, some proteins are starting to come through. All right, let's divert from waste and make sure we go to our fraction collector. We want to be collecting right now. So there's some neat communication that can happen between these pieces. You know, it's like thinking about when you did column chromatography and you had to do a TLC plate in order to see what was coming off. This is sort of doing it all for you. So what I've kind of drawn along here, and I'm going to give these number ones, this is kind of the number one pathway, okay? And we could either be going either one here. When we're in the number one pathway, we're going to call this the main line. We've got nonstop, and so there's no passenger pickup. Okay? So when you loaded a column in organic chemistry, you literally physically took your sample and you put it on top of the column. What's kind of neat here is we're going to have a bus stop that allows us to load and pick up our column. So that's what this sample injector is for. So I'm going to come up here and I'm going to put in another piece here that's called our sample loop. And this is where our protein is going to be. So when we want to load our column, we're going to do it through this sample loop. So what's going to happen is we're going to take an offshoot there. We're going to actually turn a knob in that sample injector, and just like a bus would turn off the main line to go into the parking lot to pick up passengers, that's essentially what we're doing here. Now what happens is after we stop at the bus stop and we pick up our passengers, we're going to come back down to the main line and we're going to go to the column. And then we continue along the same pathway as we had before. So we'll see how this works in a minute on a picture, but this allows us to load our column. So let's write down here our number 2 pathway is going to be our bus stop. We're going to stop at our sample loop and pick up our passengers, which is going to be our protein. That's how we're going to load our column. So I'll give you guys a minute to finish sort of writing, see if you have any questions on that. And then what I want to do is I'm going to flip back to that other picture that I was just showing you, which is a picture of the instrument, and we'll kind of point out where all these pieces are. All right, so let me come back here and I'm going to share my computer screen. I'm going to come back to this little picture. Okay, everybody see the picture of the instrument here? Okay, so I've got a flask here that's labeled water. That's essentially the same thing as a flask that would be buffer A or buffer B. And I'm going to zoom in a lot here just so that we can see things. Do you see how there's 2 tubes that are in here right now? Normally, one of those tubes would be in my A buffer, and one of them is going to be in my B buffer. So this is the start of our line, okay? So this is where we're picking up our mobile phase to kind of go through this whole system, okay? So if we looked at your scheme right now, we can see that the next thing that we're supposed to go to is our mixer. So let's trace and follow these lines here, okay? We can see here, yep, they go to our little mixer. Our mixer even has a little line that says this one's supposed to be in the A flask, this one's in the B flask, okay? Everybody see this okay enough? Okay, this is literally like a little blender. It's got a little spin bar in there, it spins around. It's going to mix whatever proportion of buffers A and B we say need to be there, and then it's going to put it through now as a combined solution. So if we look at your little scheme that you drew, the next thing that we're going to get to is our pump. So our pump is actually down here. If we kind of trace this line down here, it kind of goes out of sight for a minute. Here it is right here. But what we're going to have is it comes down to our pump here. So this is a little peristaltic pump that's in here. And so we're going to have solution kind of come through this peristaltic pump. And then I think we're going to have a little, this is too big for me to see right now. Come on. Okay, our next stop is our sample injector. Oh, here we can see it is coming up here. So right coming up here, this goes to our sample injector. Okay, this is equivalent of like our little bus stop. So I'm going to zoom in here so we can sort of see this. So right now, this is set up that we are stopping at the bus stop. Okay, so let's kind of see if we can see what's happening here. This is our line that's coming in. And this is a little knob that the openings inside this knob are where the black line are. So right now I can just follow, this comes in here, and I've made a detour to go through what I'm calling my sample loop. See this little thing that says sample loop right here? So I'm going to be traveling and picking up passengers that are in this sample loop. And then I'm going to continue to go to my column. Does everybody sort of see that there? So this little knob turns. So imagine for a second, I turned this counterclockwise, so that this opening right now is at 12 o'clock. This guy now is at 10 o'clock. Okay. What that would mean, all of these little pieces turn, a little bit counterclockwise. So now what this means is this was my line coming in. It would immediately come right back out. This would be my main line. I wouldn't be engaging any of the rest of this. That's like my bus going right by on the main line, not pulling into the parking lot, okay? If it's in that spot, what happens is when I would load my sample here, it would just kind of come out, or it would just come right out. This is to waste here. That's why there's a clip there, okay? So this is really my bus stop, if you will. This is where I can change whether I've told my bus to come pick up my passengers or stay on the main line. Okay, everybody with me? Let me know if there's anything you need me to sort of repeat. So remember here, the next thing, go ahead, yes.
Sorry, so what's the point of having like the sample loop, like of adding more in? You know what I mean? If you're already having stuff come in from like your main line.
So the main line only has buffer. It doesn't have our sample. So imagine if this was your column in organic chemistry, you had to physically add your stuff to the top of your column. Wouldn't it be really nice if there was like this little side bubble in your column where you literally could just put your sample in there and it would just get auto fed in? That's kind of what this is. It's an auto feed into the continuous line that we're running here. So Corinne, did you have a question too? Someone had, no? Was there someone else who had a question?
I just thought of one.
Yeah.
Why are there so many different tubes? Like, why can't it just add it into one tube?
Well, we initially start with 2 tubes because we want to be able to have the option of having literally an infinite number of concentrations. When we learn on our next slide what buffer A and buffer B are, we'll learn that depending on the ratio that we mix them together, we can have any one of a number of different concentrations. So if you think back to organic chemistry, you didn't just have one buffer. Maybe you started with one solution and then you had to switch to a different solution, maybe a different polarity of your solvent. This allows us to do that automatically and through a gradient. Okay, good question. Other questions? All right. What I want to do now is sort of talk about, oh, I didn't finish here. Let's keep going. So we've come through now. We stopped at the bus stop and we picked up our passengers and now we're going to our column. So let's follow our line along here. It's probably going to get lost a little bit as we kind of get jumbled here. So let me zoom out. Okay, so we've got this is coming along and is, oh, actually, this is a bad picture because it's not connected. Normally this line would come out and it would connect up to the top of my column here. Okay, and it would then load everything into my column. Okay, and then as stuff came out of my column, if you look at your chart, the next thing that we're going to go to is the UV detector. That's right here. Okay, it's going to go in and then come out of my UV detector. Then the next thing it's going to go to, here it's coming out of the UV detector. It's going to go into, this is, I know it doesn't look like much. This is a little conductivity meter. It's just something that measures the saltiness of the solution. And then it's going to come out here and it's going to come over, and you can't actually see this because it's sitting next to here on this picture that I took. I didn't take the whole thing. My fraction collector is sitting over to the left here. And so there's that little dive, whether we want fraction to be good or not, it'll turn on or off, and we can either collect fractions or not. But that's the whole route, sort of start to finish. Okay? Questions? All right, so what I'm going to do now is I'm going to flip back to my iPad here.